Hi students, this is Ms. Johnson with 7-1 Multiplying Monomials. Our subject is we are going to be able to multiply and simplify monomial expressions. Alright, let's go ahead and get some vocabulary words. We have 4 of them today. First of all, what is a monomial? Well, a monomial is a number which can have a variable and it can have an exponent. There is no adding, there's no subtracting, and there's no dividing. For example, 10 is a monomial. It's one term. 4h squared is also a monomial. But f plus 24 is not because it has adding, and 2 divided by f is not a monomial as well. Alright, product of the powers rule. Well, a product of the powers rule says if you have a problem like b to the third times b to the fifth, we can go ahead and simplify this and get b to the eighth. It says you can just take these two exponents and add them together because you have the same base. The reason behind this is because b to the third really means b times b times b, and b to the fifth is 5 of them, b times b times b times b times b, and altogether when you multiply them you have 8, so b to the eighth. So when you have the same base, you can just add the exponents. Alright, next vocabulary word is power of a power. So this one was product. When you're multiplying, this one is power of a power. And this is when you have things that look like b to the third power to the fifth power. You've got 2 exponents, 2 powers. So a power to a power says that what we can do is we can just multiply the exponents. We can do 3 times 5 to get 15 for our exponent. And because this is b to the third and we have 5 of them, this means that we have b to the third times 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 b to the third. We have 5 of them, so then you can just add up all the exponents, 3 plus 3 plus 3 plus 3 plus 3. That gives us 15. So when you have a power to a power, the shortcut is you can just multiply the exponents. Alright, and the last one is the power of a product. And this one is a little bit more complex. This one says when you have a problem like negative 2x y to the third, and then everything in parentheses to the 5th power, what we're going to do is everything gets raised to this 5th power, and it's kind of like it gets distributed to each thing inside. So it's like negative 2 to the 5th power. Well, negative 2 to the 5th power, remember it means negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Well, that gives us negative 32. Then the 5 gets distributed to the x. Well, x to the 5th power is just x to the 5th power. And then 5 gets distributed to the y to the third, and this is just like our power to a power, y to the third to the 5th. We can just multiply, so we get y to the 15th. So the power of a product rule is kind of like distributing the exponent to each thing inside the parentheses. Alright, let's go ahead and do some practice with this. Number 1 says simplify each expression. If we have 6n to the third times 2n to the 7th, we're going to simplify this. And what we're going to do is we're going to start off by multiplying the whole numbers. So we're going to do 6 times 2, which is obviously 12. Then we're going to multiply our variables that are alike. In this case, we've got n to the third and n to the 7th. These are like variables. And our power rule says we can just add the exponents when the bases are the same, so 3 plus 7 is 10. So our simplifying gives us 12 times n to the 10th power. Moving along to example B, we have 3p t to the third power times p to the third power t to the 4th power. And in this case, just like up above, we are going to start off by multiplying our whole numbers. Well, we've got our whole number 3 in the first set of parentheses. There's not a whole number in the next part. Remember though, there is like a 1 right here. So it's like, let me put a little 1 here. So it's like multiplying 3 times 1, which is obviously 3. Then again, we're going to multiply our like variables. P times p to the third. And remember, if there's not an exponent, there's really a 1 there. So p to the first power times p to the third power. Our shortcut says we can just add the exponents, so 1 plus 3 is 4. Then let's go to our t's. We've got t to the third times t to the 4th. Again, add the exponents because we have the same base, and we have t to the 7th. So our simplified answer to this problem is 3 p to the 4th t to the 7th. All right, moving on to our next one, power of a power rule. First example says if we have g to the 6th to the 7th power. And our power to our power rule says we can multiply these two exponents when it's a power to a power. So 6 times 7 is 42, so we get g to the 42nd power. Now our second example here, letter B, is a little bit more complex. We've got 2 to the 3rd to the 2nd to the 4th power. We have lots of powers to powers to powers. And what we want to do is we just want to take it step by step. We want to start inside the parentheses and work our way out. So first thing we're going to do is 2 to the 3rd power. All right, 2 times 2 times 2. All right, that is 8. Let me back up just a second. My bad. All right, 2 to the 3rd power to the 2nd power. We want to start inside. So we've got a power to a power. So 2 to the 3rd to the 2nd power, we get to multiply the exponents together, and 3 times 2 is 6. So we've got 2 to the 6th power, keep our brackets, and then we still have this 4th power outside. So now our problem is 2 to the 6th to the 4th. Again, apply the power to a power rule. So 6 times 4 is 24. So our answer is 2 to the 24th power. Now in this example, we have all numbers, so we can actually simplify to figure out what this is. And if you punch it on your calculator, 2 to the 24th power, we get 16,777,216. All the other ones I've given you so far have just had exponents, and we've simplified them as far as we can. All right, our third and final example combines all of these power rules together. We have 3xy to the 4th, all to the 2nd power, and then we have times negative 2y to the 2nd power, all to the 3rd power. And this problem, I know it looks a lot crazier than the last ones, but just go step by step and you will be able to figure out the answer. So what we're going to do is let's just start with each part. We're going to take, let me switch my color here real quick. We are going to take this part and treat it as kind of one problem to begin with. And we're going to take the part on the right and kind of treat that as a separate problem for right now. And then we're going to combine them together at the end. So the 3xy to the 4th to the 2nd power, we have the product of the powers. So what we're going to do is we're going to distribute the 2 to each thing inside the parentheses. So we're going to have 3 to the 2nd power, x to the 2nd power, and y to the 4th to the 2nd power. And I have it written out right down here so you can see that. And we'll take the part on the right, and again we're going to distribute the exponents through. So we're going to have negative 2 to the 2nd power, and notice I put that in parentheses, and make sure you keep that negative. Distribute the exponent of 2 to the y, and for right now keep your brackets and keep that other exponent of 3 there. Alright, now that you've done that, let's simplify. Okay, what we're going to do is 3 to the 2nd power, that's 9. X squared stays x squared, and y to the 4th to the 2nd is y to the 8th. We can just multiply those two exponents together. Alright, then the part on the right we're going to distribute, and we've got to simplify negative 2 to the 2nd power, and negative 2 times negative 2 is positive 2. I'm sorry, positive 4. So we've got 4, keep our y squared, and keep our brackets, and keep the 3 as the exponent outside. Alright, so this part on the left, there's nothing more to do right now, so we're just going to focus on this part on the right. Again, we have a power to a power, so we're going to distribute this exponent of 3 to each thing inside the brackets. So distribute the 3 to the 4, and distribute the 3 to the y squared. When we do that, we get y to the 3rd, and y squared also to the 3rd. As we simplify, 4 to the 3rd power is 64, and y to the 2nd to the 3rd power, we can just multiply. Sorry about that announcement. So as I was saying, y to the 2nd to the 3rd power, we multiply those together, and we get y to the 6th. All right, at this point we are now ready. We are simplified as much as we can with each part separately. Now we're going to combine them together. So right now it says 9x squared y to the 8th times 64y to the 6th. So we are going to go ahead and multiply. So just like we did in example 1, we're going to multiply our whole numbers, and 9 times 64 is 576. Our x squared, we don't have any x squareds over here, so we're just going to bring that along. And then y to the 8th times y to the 6th, we get to add those exponents together because they have the same base, and we get y to the 14th power. Okay? Step by step by step, we can take care of it. All right, it is summary time. Just a reminder, you should have a sentence for each example in your summary, and you should do your summary right now at the bottom of your notes or on the summary sheet tomorrow morning. Thanks for tuning in. This is Miss Johnson with Multiplying Monomials.